this is Aaron Dominion, and this is the Creation Kit scripting series, Papyrus tutorials. This episode, it's the variable second part, and we're going to go over variable manipulation. Now, what will be covered? How to manipulate the various variable types that we went over in the first episode, string, integer, so on and so forth. If you aren't familiar with those variable types, please look at the previous episode. Otherwise, you should be good to go, and if you already know how to do this, then you can skip it. Alright, so let's look at a boolean. It's probably the easiest one to manipulate, because variable assignment's the only thing a boolean can do. It can either store true or false, like we covered, so you can only assign true or false values to it. Now let's go over manipulating an integer, probably one of the biggest variable types that you will use. So, what operations do you have? You have equals, you have addition, you have subtraction, you have multiplication, you have division, modulus, which I'll go over a little bit, parentheses, so you can make complex expressions, and then negating, which it uses the same symbol as subtracting, but I'll go into details over what that is. So, let's go over addition. So it performs exactly like normal addition. 1 plus 1 equals 2, count equals 2, then you have count equals 2 plus 1, which makes it 3. You can add itself, so you can have your variable equals your variable plus a number, or plus another variable. The example I give here is you set count equal to 2, then you have count equals count plus 1 to make it 3. For adding variables to itself, you can also write it as plus equals to save on writing space, but it means the exact same thing as count equals count plus 1. In this example I have here, count equals count plus 1 can be written as count plus equals 1, because it essentially translates to count equals count plus 1. Alright, we'll be going over all of this in the let's try what we're going to do section of this video, so don't worry if you're still a little confused on that. Subtraction. Alright, so it's again, this is like addition but subtraction this time. 1 minus 1 equals 0. If you have a variable named count, that was initially 2, and then you subtract 1, it will be 1. Just like addition, you can subtract the variable itself from itself. Count equals count minus 1, as in this example. And then you can also, just like in addition, rewrite it as minus equals. So count equals count minus 1 can be written as count minus equals 1. Sometimes that's better to do just so you save on space and it's succinct, but if you want to know what is actually going on, the equals method might be better. In all of these cases that we're going to go over, we're as minus equals, plus equals, so on and so forth. Alright, so let's go on to multiplication. Again, it performs exactly like normal multiplication. 1 times 2 equals 2, or health multiplier equals 1, and then you multiply it by 2, changes it to 2. You can multiply the variable to itself, like health multiplier equals health multiplier times 2. And you can also rewrite that as times equals. So health multiplier times equals 2 is the same thing as health multiplier equals health multiplier times 2. And again, all of the same considerations when using times equals, as opposed to equals the variable times the new value. Alright, so division is where things get a little bit more complicated in integers, because you don't have any remainders in integers. So for division that there's no remainder, the result's the same. 4 divided by 2 is 2, 20 divided by 5 is 4, and so forth. Division on decimal values, however, the number's truncated, no matter if it could round up, like 4.9 rounding up to 5. Nope, Papyrus does not do that. It just cuts off the decimal value and gives you the number in front of the decimal. So 29 divided by 6, it would usually round up to 5, but nope, it's going to be 4, because it cuts off the decimal. 9 divided by 4 is 2. Similar principle going on there. Just like the other variables, you can divide itself. So you have count equals 10, count equals count divided by 2. It makes it 5. You can also write it as divide equals if you're dividing a value to the current variable. So if we look at the count equals 10, count equals count divided by 2 example, count divide equals 2 is the same thing as count equals count divided by 2. Alright, now another interesting concept is modulus. Remember those remainders you can't get? Well, with modulus you can actually find the remainder in the division. So, where things are evenly divided, 9 mod 3, in this example, it's 0 because there's no remainder. 9 mod 4, it's 9 divided by 4, that returns a 1, because that's the remainder in that case. 7 mod 4, or negative 7 mod 4, excuse me, returns negative 3, because that's the remainder in that division, so on and so forth. If mod's weird to understand, you can rewrite it as the first variable. So if we look at the 9 mod 4, 9 minus, and this is where parentheses come into play, that we'll go into in a moment, your second variable, so 4, times, and now another set of parentheses, your first variable divided by your second variable, and then you end both of those parentheses. Just if that's an easier way to understand what's going on in a modulus operation. You can mod itself. It might get a little weird doing it, but you can. So like even number equals 2, even number equals 12 mod even number. I think it should be the other way around, but the value's 0 either way. And this is the confusing part. You can write it as mod equals. So even number equals even number mod 2 can be written as even number mod equals 2. Which, since there's no remainder, if we have it equal to 12, it will be 0. So what would you use modulus for if you're not familiar with modulus is? Well, the primary purpose that most programmers out there use it for typically is determining if a number is even or odd. If you need that for whatever calculation that you're doing, or if you want to do a cool feature, oh hey, if the amount is even, do this, if the amount is odd, do this. Could be used for gold prices and things like that, but I don't know, I haven't used modulus in Papyrus specifically. It can also be used if you need to have a remainder for precision calculations on larger numbers, or on numbers where it's integers but you still want precision in the end without using messy float logic, since floats are typically not desirable over ints unless if they are required. Alright, so parentheses. They are used to separate equations. I did a simple example here. I don't have any variable examples listed on this page, but replace the numbers here with variable names and you'll get similar results, like parentheses 4 plus 2 plus parentheses 3 times 4. What will happen because of the parentheses? Think of your order of operations. The things in the parentheses left to right will be evaluated first, so 4 plus 2 will be evaluated in 3 times 4, and the result of 4 plus 2 will be added to the result of 3 times 4. Okay, so you can use parentheses as an implicit multiplication if you have them next to each other. For example, remove the plus sign in the example above. I removed the multiplication for 3 times 4 and had it 3 plus 4. So it's 4 plus 2, which is 6, times 3 plus 4, which is 7. And yeah, you can do the math there. 4 times 3, 12. This is mainly used to create parentheses are mainly used to create complex formulas or add different expressions together. This is useful if you're trying to make your own rates or rate logic, especially if you're doing profits for something. I've used them before for calculating mine profits in one of my mods. Okay, negation. This is something looked weird on the list of assignments, but it's pretty simple. Count equals 1, and then negative count equals minus count. Basically, you're just giving the opposite of the current value whenever you put a minus sign in front of a variable. Alright, let's move on to floats. This should be pretty easy since a lot of the same concepts for integers apply to floats. So, addition, subtraction, multiplication, parentheses, and negation are all the same as integers whenever it's with floats, except you might have decimal points this time. It uses all the same symbols. On this minus var, I just did that for the negation to show you, oh hey, you use the minus sign in front of the variable name. Okay, division. It performs the same as integer division on results that are not decimal values. It will put a decimal point, like 0.0 or something, on there, but it essentially works the same. It does not truncate results where there are remainders, though. And it will only contain a decimal supported by 32 digits. So if you have a really large number, the decimal will be smaller. If you have a smaller number for the result, the decimal probably will be larger, depending on what the remainder is. And it uses the same symbols as integer division, so no worries there. Modulus is not supported for float types. So if you need to do even odd calculations, you will have to do something different, which you might have some ideas later in this video on how to do that. Okay, manipulating strings. There's not much that default Papyrus gives you for that. You can assign strings, double quote designates, oh hey, this is a string, and then concatenation, which I will go over now. Concatenation, you're basically you're taking two strings and creating a new string with them together. So the examples I have here, at least, and then you use plus to concatenate. My KD is positive translates to at least my KD is positive. Notice here there's a space. You have to designate the spaces whenever you're doing concatenation. Otherwise, if you had no space, at least and my would have been one word. Alright, let's look at another example. Frodo Baggins is being concatenated, and it translates to Frodo Baggins. Manipulating objects. I'm going to just go over this really quick because some of the object operations work for the primary types. So, but we'll go over this in more detail whenever we get to the objects portion of the Papyrus tutorials. So we have variable assignment, casting, that's a big one, and then the dot to call a function that the object has. So casting, transform your current object into another object. In this video, I'm only going to show you the primary types, converting them, because that's an important concept for what we're doing. So, we have an integer, say count equals 1. Well, what if we want it to be a float? So we are assigning a new variable, float count equals, parentheses, count as float, meaning the integer is being turned into a float object. Yes, the primary types can be objects, but we'll go over that in more detail later as well. Another example I have here is count equals 1 again, and then you're making a string version of it, so you cast count as a string. Okay. Calling a function, don't worry too much, just covering it as a basic operation. All objects, like actors, object references, so on and so forth, have methods attached to them. Let's consider the game object real quick. Game.getPlayer. GetPlayer is your function and it returns the player. Another example that we use for hello world, debug being the object, and then dot messagebox. Messagebox being the function, and it was passed the string hello world. Okay. We're going to do arrays really quick, although we're not going to cover it much in this episode. So, basic operations, whenever you're calling your array, if you want to have a specific index, because an array is basically a list that can't expand at all, at least in programming terms. We'll go into more detail though about what Papyrus does there in a different video. You just call the index, I being the value spot that you're trying to get to. Equals is the only symbol that you can use when assigning new values to an index. So if you want to do any addition or calculations, it will have to be done after the equal sign. Again, don't worry, we'll be covering arrays in further detail later. Alright, so important concept here that we went over in the casting part of the object manipulation is mixing variables. So, integers with floats. All floats need to be converted to an integer before you try to assign it to another integer. Let's look at just one example before we actually go into programming example. You have this integer count, and then you have a float that's equal to 0, and you have yo as an integer equal to 1. So, in order to use that float in the same calculation as yo, you have to cast your float as an integer before adding it to yo and assigning it to count, as seen in the last line here. Now, it's a lot easier the other way around, floats with integers. All ints automatically convert over to floats when assigning to a float. At least that's what I'm remembering. If not, just do a cast as int. Or not cast as int, cast as float, and it'll convert it. But here's an example that we using a float of count instead of an int of count, going yada yada yada, and then you just add the float to the integer. Alright. Integers and floats with strings. To incorporate an integer or a float, you must concatenate with your current string or an empty string. Alright, let's go over two examples. So we have one with integer and one with float. So we have a string that we declare but not assign anything to it. We have an integer, then we're adding we're using an empty string. That's what happens when you have blank space in between two double quotes to yo, and that empty string will then become your variable, but now it's a string, not an integer when you do that. And let's look at the float example. Yeah, it will keep all the formatting that a float would have typically, but again, it's not a float anymore once you assign it to the string. Alright, general rules for doing this. Cast objects that are similar to each other. I don't try casting a string as an integer if there's text that's not numbers there, or if it's a float. That would just cause weird compile errors or weird behavior if it does compile. Cast floats as ints only if precision doesn't matter for whatever calculation you're doing. That's it. Let's actually put this stuff together now and test it. I should have probably loaded this before, but let's just load it now. This is the same mod file that I was using for the Hello World example. You can use a new new ESP if you want. I'm just doing this so everything is together, since I do this for testing. Normally, this is my mod idea testing ground. Okay. I have Notepad++ opened up. You should have it open up too before we get started. This is an example I was doing. Not an example, but something I was doing for somebody else for a feature that's pretty exciting. And here's the Hello World. I disabled it though, so we don't have the Hello World message box whenever we're trying to do this. Some things to have open, maybe, for doing this. Not that. On init, just if you need this again. Here's the operator reference. Let's look at the URL there. Okay. And it goes through all the different operators. There's a few operators here that we'll go over in the next episode. That's comparing variables. And literals being like equals and things like that. They use expressions here to tell you what's going on with a float or an integer, whatnot. Don't worry too much about that if you don't understand. And then, if you need to look at information about modulus, Wikipedia has modulo operation. Okay. So this is loaded up now. I create a variable cell for testing, and I have a variable test script, and not much in there. So let me go to the source folder that I have opened, and now let's open up the variables script there. Okay. And always start off with a comment tree. I'm going to use my style for readability's sake. Don't worry too much about the input and stuff. We'll cover that whenever we get to events and functions. This event will be called at the beginning of existence, and will perform variable tasks. So let's keep these numbers, but have it for our example that we had earlier. Okay. So our integer values. And we're going to, this is bad form what I'm about to do, but it's easier to do it this way. Copying code is typically a bad idea. So let's do this real quick. And this is where we're going to do integer initials. So you can just pass in the name here for each, and in game it will just show up the values. Now let's do integer operations. So we're going to create a new int. Changed value. Let's keep consistent style, since I talked about that in a previous episode. So changed value. Let's add to it. Add equals changed value plus 1. And let's give it changed value. And then let's do a plus equals, just so you can see the effects of a plus equals. Okay, so that's adding. Let's subtract. Changed value equals changed value minus 1. And so you can see the same effects. Minus equals 1. Changed value. Okay. Now let's go over multiplication here. Please follow along and code this up yourself so you can see it in game. It will help a lot for your understanding about the operations. I notice some are visual learners and such. Alright, so we can actually see something going on here. We're going to do a value of 2. A value of 1, multiplying it to itself just will give you the same value. And let's do the times equals variety of that. Okay. Now division. So at this point, just so it does actual change, we're going to reassign changed value to 2. Okay. Because in our current logic, before I added that line, at line 32, it would have been 1, and 1 times 2 is 1. Or no, 2, excuse me. Alright. So, changed value is going to be divided by 2. And we're going to print that out. And let's do a changed value divide equals 2 to show the effects there. And for the purposes of seeing what happens when the value doesn't agree, let's change changed value. Alright, let's see. 3. 5. And then changed value divide equals 2, and let's print out the new value. Okay, let's do modulus here real quick. These integer values that I declared at the top, let's do that real quick. Int modulus number equals number mod divided by, and mod's the percent symbol on your keyboard if you can't see it in this. Let's do that. That doesn't help too much. Alright. And let's print that modulus number. Okay. Let's do parentheses example. So int random formula. And in this formula, we are going to multiply changed value to itself plus our modulus number divided and multiply it by, let's see, number mod changed value. And there's our formula. I don't know what that is, it's just something that came into my head. Let's evaluate that and see what that result is there. Alright, let's do a negation example. So, int neg changed value. Neg changed value is going to equal the opposite of changed value. For the purposes of this test, I'm going to have it print changed value, and we're going to print neg changed value. Okay. So that should be integers. Let's go floats. Float. Hey, I am a float. That is a bad variable name, but oh well. Addition. Oh, we need to give it a value. That's always an important thing, to give it a value. 1.0. Just so we keep it similar style. A float equal case is not important, but keep the same style for readability's sake. I'm going to reduce this variable name just let's see, just so it's easier to type. Okay. And then we're going to print out our float. And just so you can see it, it's this message type. Okay. So let's do subtraction. This example, I apologize for the Steam messages. I should have probably disabled Steam while I was doing this video, at least the community side of it. Alright, so minus equals 1, just to show you the example, the effects here. And let's do multiplication. Let's reassign our float to 2.1, just so we can do some things with it. Float var. Let's keep it the same, multiply it by 2. Print out the message, and then float var, we're going to do a time equals 2, and it should give us similar results there, except it's going to be different, of course, since we're not reassigning it. Alright, division. This is going to be where you'll probably notice the big difference between integers and floats in the operations here. So we're going to do what we were doing a moment ago, except divide by 2. And you should notice that should be the value before we did times equals. And then divide equals 2. You should notice this value be 2.1. And no modulus, although we'll do parentheses and negation here. So float, random float formula, and in this random float formula we are going to 2.0 times 3.0 divided by 5.5 times and then this is going to be the float var. And let's just do that and print out our let's do a simple negation example here. So float neg float var, and neg float var is going to equal minus float var. And let's print out the 2 just so you can see it again. By the way, these message boxes, they're good only for debugging purposes. Don't use them in actual end scripts. Okay. So that's float. Let's do our strings. We could have done Boolean, but that's not really important for this video. So string hey. Hey is going to equal hey. And now we want to do a message box to print hey. Okay. So let's do a concatenation example, string there. And we'll have that equal to the word there. String combo. Combo is going to equal hey plus the empty string with a space in it, and then there. And let's see what combo says. And that should be all of the string stuff there. We're not going to do objects or arrays in this example, so don't worry about that. Let's do mixed types now. So an int mixed with float mixed with float is going to equal changed value plus, let's do our negative float var as int. Okay. Now let's do a float mixed with int. Mixed with int is going to equal, not gloat, float var plus neg changed value. I believe that's the name that we used. Yep. Okay. Let's print out our mixed with float. And let's print out our mixed with int. And now our string mixed with int. And let's do a string mixed with float. Our mixed with int is going to be combo plus the empty string plus, let's give random formula some love there and print it. Now let's do the same example for float. Excuse me, I should probably do this, so it's going to be combo again, just so we have the space there between hey there and the formula. And let's use our random float formula. And let's print out that. Alright, so something that I just noticed, those variable names for integer mixed with float, mixed with int, mixed with float with mixed with int, yes they will work, but no, you don't want to do them. So let's do that. So it's different name. Good form to not reuse variable names. It will be confusing that way. And whenever you wanted to print it there, it would actually not know what to do. That's the sad thing. Okay. We need to change these as well. Okay. We should be good now for see it all here. Let's save. Line 95. I messed up the formula. Okay, let's see if this fixes the issue. If this does, then I am sorry about that part in this video. Let's see. Okay, that fixed that issue. Now, $33. Let's see. Why is it oh. Okay. It didn't know what changed value was. Or not changed value, but changed was at that case. You will have these problems as you're scripting. Just read the error messages. Hey, everything compiles. Alright. I will see you in a moment. Alright, so we're loading up. So as soon as you load up, you will see the values appear that we were using. Okay, so 12 for the number, 2 for the divide by. Alright, so 3, that's our changed value. What was it? I don't know. Alright, so we have 1 for initial changed value. 8. Oh, it's doing these out of order. Okay, that's why. It's the way the script stack works. I see. I see. There's float. Notice how many decimal point values it has there. The initial vote, float. There's the multiplication there. Yeah, it's doing all these out of order, so it really can't get a good idea. You'll have to do them individually if you want to test them out. Like last week, here's my last video, here's the contact information, and it will be in the video description. Also, all the other pages that I have used in preparation of this video, or to have the functions and such that were covered in this video, will be in the video description before the contact information, just like on the variables one. And I will see everybody on the next episode.